Hey everybody, today I am doing another math problem and we're still doing 4.3 on this section, right? So the section is 4.3 and the number is going to be number 39, okay? So we do number 39, okay? So so we do number 39 and we will be doing the same procedure, right? The only thing I would like to explain is that on the last video I said that you find on step 2 you find the complementary solution, and I'm sorry about that, but I kind of I will say some books call it the complementary solution, but in other books call it general solution, but I will call it general solution because the general solution is actually the one that is in this form most of the time. When you're doing another method or when you use another method to solve differential equations, sometimes this is called also a complementary solution. This type of form like that. However, like I say, it depends on the book, okay, that we're using. Now, but it's better to call it general solution, okay? General solution, okay? So now, another thing that I would like to explain is that when you solve binary value problem, when you solve binary value problems, you actually will have initial conditions either involving the function, okay, or initial condition only involving derivatives, okay. So last time I said that you're not supposed to have a derivative when you solve this type of binary value problems, but that is another mistake that I made, because yes, you can, okay, you can have derivative, but if you have a derivative, both derivatives have to be conditioned. It have to be initial conditions. You cannot have like a regular initial value problem that you have, for example, x evaluated at, y evaluated at y of 0 is equal to 5, okay? And then you have the derivative, and then you have a y prime of 0 is equal to 2. Now, when you have this type of problems, you only dealing with either derivative or either the regular differential equation. When I mean the regular differential equation, I mean the general solution, okay? So we gotta take this in mind. Again, if it involves derivative, they both should be, the two initial conditions have to be in derivative. If we involve the solution of the differential equation, again, it's going to be only the solution of this differential equation. You cannot have one initial condition with derivative and another initial condition with the general solution. However, Another thing that I forgot to explain at sometimes when you have this type of problems, you will not have a solution. We cannot solve it if the problem we cannot solve it, then the problem will not have a solution. Okay, that differential equation will not have a solution. So I want to just explain that real quick. Okay, and again, I am doing this in a very short manner because my purpose of doing these videos is to show those students that to solve differential equations, most of the time this course is for engineering students, which means that you will learn the process how to solve differential equation without going too deep into the theory of the differential equation, because again, you need the process to solve differential equations, especially for differential equation for engineers, or sometimes it's called applied math. Okay, so again, and I think this is, I explained this last time, that a lot of times when you get to the class and you have a mathematician teaching the differential equation course, he goes a bunch of theory that at the end of the day you don't need it to solve differential equations that you actually need for engineering purposes. Okay, so I want to just explain that why I am doing it like this, because A, I don't have no big board to write everything down, and B, my main purpose over here is to try to develop a method to solve differential equations without going in too deep into the theory. Okay, so let me just erase this, and then we will do one of the differential equations. Okay, but anyway, before I'm going to explain a little quick. Okay, I already did this a couple times in the last videos, but it doesn't hurt to go through it again. Okay, it's step one. Okay, consider all the three cases, but identify only the one that applies. Okay, now in this case right here, okay, we consider all the three, but only we will identify the one that applies. What I mean identify the one that applies is that I will say, okay, I am in case 1, case 2, or case 3. Okay, now step 2, find the general solution and find C1 and C2. Plug in C1 and C2 into the general solution, right? Into the general equation. Okay, so general solution, I would say it's better. General solution. Okay, so you plug into the general solution of the differential equation. Okay, now let's go through the cases again. Case 1, we have a distant root, which means that m1 cannot equal m2. And the solution is going to be y is equal to c1 e to the m1 x1 plus c2 e to the m2 x2. Okay. Case 2, we have a repeated root. Okay, repeated root means that m1 will equal m2. Okay, and in this case, we will have. I'm sorry, I'm supposed to have an X in there. Okay. So in this case, is y is equal to c1 e to the m1 x1 plus c2 times x e to the m2 x2. Okay. Now we have a case 3. Case 3 we have conjugate complex root. Okay? Conjugate complex root mean that m1 is equal to alpha plus I beta, okay? And m2 is equal to alpha minus I beta, okay? Again, m1 is equal to alpha plus I beta x, and m2 is equal to alpha minus I beta x, okay? And the solution of the differential equation is going to be in this form, okay? Y is equal to C1 e to the alpha plus I beta times x plus C2 e to the alpha minus I beta times x. Again, y is equal to C1 e to the alpha plus beta times x plus C2 e to the alpha minus I beta x, right? Okay, so now we have the, see, we see the arrow right here, drop this arrow down here, which means that this is the Euler's formula. The Euler's formula is e to the I beta equal cosine, e to the I theta equal to cosine theta plus sine theta, right? Plus I sine theta, right? And then, so this can be translated into this, okay? This formula can be translated into e to the I beta x equal cosine beta x plus I sine beta x, right? And then e to the minus beta x equal cosine beta x minus I sine beta x, right? And this, again, this is called the Euler's formula, okay? So now, let me erase this, and then, so I can start working on the problem. So, let me erase this, and then we will do problem number 39, okay? So number 29, in the same book, okay? So number 39 in the same book. So we'll do the same thing. 4.3, homogeneous linear equation with constant coefficients. And we do in number 39, which says solve the given boundary value problem, right? So number 39 is as follows, is y double prime plus y equal 0, okay? And I got y prime of 0 equals 0, and y prime of 0 again equal, this is not 0, this is pi over 2. This is pi over 2, right? So this is equal to 0, okay? Now, I don't know if you can see the pi over 2. Let me just erase this and make it a little bigger. So y prime pi over 2 equals 0, okay? Now, let's do this problem, okay? Let's start by finding the root, okay? Let's start by finding the root. Well, the roots are it's going to be m squared plus 1 equals 0, right? Notice that I have a homogeneous differential equation because it's equal to 0, okay? So now, to solve this, I'm going to subtract 1 on both sides, and I got m is equal to 1, right? Negative 1, okay? And then if I take the square roots on both sides, okay? So what do I get? Okay? I get m is equal to plus or minus 1, okay? Okay, so let's see. Plus or minus 1, okay? Be careful. Okay, plus or minus I, okay? Plus or minus I, okay? Now, if I have a plus or minus I, what case applies in this case? Well, it's case 3. Why is it case 3? Well, because we have imaginary number, okay? We have an imaginary root. We have a complex root, in other words. So we are in case 3, okay? We are in case 3. So we did a step 1 already. We identify what case applies for this problem, okay? So the general solution is going to be y is equal to C1 C1e, I'm sorry, nope, this is not right. Okay, first of all, I'm going to explain a little quick on this, okay? So what I found right here is the root, right? Which is a complex root. Well, m was supposed to be equal to alpha plus I beta x, right? And m1 and m2 to be equal to alpha minus I beta x, right? Notice that this over here, I don't have an alpha, okay? So that means that alpha is equal to 0 and beta is equal to plus or minus 1, which is the coefficient of I, right? So beta is equal to plus or minus 1. Beta is equal to plus or minus 1, okay? So I am doing this just to identify what we're doing in this case, okay? So the formula because alpha is 0, okay? The formula to be just in the general solution is just will be C1 cosine of x plus C2 plus C2 sine of x, right? But if I had an alpha, this will change it because the formula, it was going to be, in this case, it was going to have attached like e to the alpha x, okay? So it was going to have an e to the alpha x, okay? But in this case, because I don't have an e to the alpha x, if I plug in, we say that alpha is 0, right? If I plug in 0 for, in this case, any number time to the 0 power, okay, is 1. So anyway, that is the case, okay? So that's why I didn't have, it was not necessary to put the 0 in there, because we know that e to the 0 power is just 1, right? So if e to the 0 power is 1, this whole thing becomes this, okay? Because if we substitute that, if alpha was 0 and we say e to the 0 power is 1, and then this whole equation becomes c1 cosine x plus c2 sine x, okay? So now this is general solution, okay? Let me just find the derivative of this, okay? Let me take the derivative. So y prime, why I'm taking the derivative, okay? Because the initial conditions of these problems are just given in derivative. Notice that I have y prime over here, 0 is equal to 0, and y prime of pi over 2 is equal to 0. So I have two derivatives, right? Like I told you, either have to be in the general solution form, or it has to be in the regular derivative form. In this case, it is a derivative because I have to take the derivative of this function in order to get it in this form, okay? So now let's do the derivative. Y prime is equal to, the derivative of cosine is negative sine, right? So negative c1 sine of x, okay? The derivative of sine is cosine, so it will be plus c2 cosine x, right? Now let's find c1 and c2, okay? So if I plug in 0, okay, and I let y prime is equal to 0, then 0 is equal to negative c1 sine of 0 plus c2 cosine of 0, right? So look at this. The sine of 0 is 0, right? So 0 is equal to, and then cosine of 0 is 1, so 1 times c2 is c2, right? So I get that c2 is equal to 0, okay? So c2 is equal to 0, right? So c2 is equal to 0. Now let me find evaluated pi, okay? If I do that, then it's going to be hopefully the camera can see right here, okay? So c2 is 0. So C2 is 0, right? We say that C2 is 0. But just let me just have the process so yeah, how it's done, okay? So C2 is 0, okay? Now, let me just plug in pi, okay? So it's going to be 0 is equal to negative C1, okay? Sine of pi, okay? Pi over 2, okay? Now, plus C2, well, but what is C2? C2 is 0, right? So 0 times cosine of pi over 2, right? So this is 0 again, okay? That is 0. So, and this right here, okay, sine of 1/2 pi is 1, right? Sine of 1/2 pi is 1, okay? But remember that I get 0 is equal to, if sine of 1/2 pi is 1, then what is C1? Well, in this case will be -1, but -1 is -1 times z. In this case, 1 multiplied by negative is negative C1, right? Negative C1, but it's still 0. So C1 is equal 0. So I get that Z1 is equal 0. Okay, so if C1 is equal 0, look at this. If C1 is equal 0, okay, if I plug in 0 for this go to 0. If I plug 0 for this go to 0. Okay, so let's do it. So it's going to be y is equal to 0 cosine of x plus 0 sine of x, right? So in this case, this goes to 0, okay? This goes to 0. So the answer for this is y equal 0. Okay, so that is the final solution for the differential equation. In this case, and this is a special case, I would say, because we had a solution that came out to be 0. Okay, but that's how you do it. That's how you do these problems. Okay, so notice that we identify the cases. After we identify the cases, we find the general solution, and then after we find the general solution, we substitute the values given on the initial conditions, which is, in this case, we have to take the derivative before we did anything, because it is, both of them have the derivative. Okay, so we did that, we took the derivative, and then we came up with this function. Okay, and then after we did this, we plug in the values of the initial conditions, right? And then we found C1 and C2, which they, in this case, they became to be 0, okay, both of them, and then we plug it into the general solution, and we got that our answer was 0. Okay, so that's how you do this problem. Okay, thank you for watching, and I will not be doing more of this problem. If I have a time, I will be doing different sections. Okay. Thank you.